Good afternoon everyone. In the last lecture we have discussed how to find out the distribution factor and coil span factor, that is Kc and Kd. In this lecture we will discuss the problems based on the EMF equation. Okay, so let's start with the first problem. Now read this problem. A 3-phase 50 Hz 16 pole star connected alternator has a stator winding with 144 slots with 10 conductors per slot. The magnetic flux per pole is 0.03 Weber and is sinusoidally distributed in the space. The coil pitch of the winding is 8 slots. Now estimate the EMF induced between the lines of an alternator. So this is the problem. Now very firstly we have to write down the given data. Now again we'll go line by line. Now see, a 3-phase 50 Hz 16 pole. So we have got here the number of poles P. So see here, this first given data, P is equals to 16. 16 pole star connected alternator. So our alternator is star connected. Okay, has a stator winding with 144 slots. So how many slots we have? 144 and 10 conductors per slot. Okay, the frequency is 50 Hz. So this is the given data. Now next, the magnetic flux per pole, that is they have given phi. So phi is equals to 0.03 Weber, which is sinusoidally distributed. Then the coil pitch of the winding is 8 slots. Okay, so we have to decide now whether this is a full pitch or short pitch. But coil pitch here it is of 8 slots. And then we have to estimate the EMF induced, that is the EPH. Okay, so this is the given data. Now from this given data I can find out, first I have to find out small n. Now small n is number of slots per pole. So how many slots are there per pole? That we have to find out. So there are 144 slots total. Okay, and we have 16 poles. So 144 upon 16 is 9. So n is equals to 9. Then m is slots per pole per phase. So this is slots per pole. Slots per pole, that is n, which we have got as a 9 per phase. So here we are having 3-phase winding. Okay, as they have stated here, 3-phase. So we have R, Y and B phase. So n by 3. N is 9 by 3. So m you have got 3. Okay. Then beta. Beta is the the phase difference contributed by one slot. Okay. So this beta is equals to 180 upon 9. This is the formula for beta. 180 upon n. So n is here 9. So 180 upon 9 is 20 degree. Okay. This all the terms, this n, m, beta, alpha, whatever we have used here, I have already discussed and derived this in my previous videos. If you have any confusion with this, you should go back and see my previous videos. Okay. Then to find out, what we have to find out is the EPH. Okay. Now for full pitch, the coil pitch should be equals to n. And how much is n? N is 9. But here they have stated the coil pitch of the winding is of 8 slots. So this means that our coil is a short pitch by 1 slot. Okay, actually we want our coil should be distributed in the 9 slots, but actually coil is distributed in n slots. So our coil is not full pitched coil. It is a short pitched coil and it is short pitched by 1 slot. Okay, so from here I can find out alpha. Alpha is the angle of short pitching. So alpha is equals to beta into number of slots by which winding is short pitch. So beta is 20 I have calculated. And our winding is short pitch by 1 slot. So 20 into 1, which is equals to 20 degree. So I have got my value of alpha here, that is 20. Same as beta. So I can find out the coil factor. Okay. So see, what is the formula for coil span factor? Kc is equals to cos of alpha by 2. So I have got alpha as 20. So 20 by 2 is 10. So cos of 10, if you calculate on your calculator, it will be 0.9848. So this is the value of a Kc, that is a coil span factor or coil pitch factor. Okay. Then we have to find out Kd, that is the distribution factor. Now this is the formula for Kd. Kd is equals to sine m beta by 2 whole divided by m sine beta by 2. So we have find out all this value. We have m, we have beta. So put this value here. We have m 3, beta is 20 upon 2 whole divided by 3, then sine 20 by 2. So put all this value in your calculator, and if you solve this, you will get the value of Kd as 0.9597. Okay. If you have any doubt about this Kd and Kc, we have detailed derivation about Kc, Kd, how we are getting beta, this m and n in my previous videos. Okay. Then to find out EPH, now see here, we have to find out EPH. The formula for EPH is 4.44 Kc, Kd, phi, f, TPH. So now we have Kc, Kd, phi also we have f, we just don't have this TPH, that is the number of turns per phase. Okay, so I have to find out this TPH. To find out this TPH, I must have the total number of conductors per phase. Okay, so first I will find out the total number of conductors Z. So Z is equals to total slots into number of conductor per slot. So we are having 144 slots, and in one slot we have 10 conductors. Okay, so 10 into 144, it will be 1440. So total conductors are 1440. Now conductors per phase, here we have 3 phases, so we have to divide it by 3. So 1440 divided by 3, which is equals to 480. So this is the number of conductors per phase. Now when I say the number of turns per phase, then there are 2 conductors in one turn. So to find out turns per phase, we have to divide ZPH by 2. So 240 by 2, it will be 2. 480 by 2, it will be 240. Okay, so you will get TPH as 240. Now put all the values of Kc, Kd, phi, that is 0.03, F50 and TPH 240 in this equation, and if you solve it by your calci, you will get TPH as 1510.6679 volts. Now this is the phase value. Okay, and our alternator is connected in star. So as our alternator is connected in star, our phase voltage and line voltage is different. And what is the relation between line voltage and phase voltage is, line voltage is equals to root 3 times phase voltage. So multiply this phase voltage with this root 3, now you will get the phase voltage as 2616.5535 volts. Okay, so in this way you have to solve this problem. Now we will move towards the next problem. Now read the problem. Find the number of loads, load phase and line. Find the number of phase voltage and line voltage of a star connected 3-phase 6-pole alternator which runs at 1200 rpm, having the flux per pole as 0.1 Weber, sinusoidally distributed. Okay, its stator has 54 slots and having double layer winding. Okay, so this is the highlight. It is having a double layer winding. Each coil has 8 turns and the coil is corded or shorted by one slot. Okay, now again we will write down given data. So here P is equals to 6. See, they have given 6 poles. Okay, then they have given the synchronous speed of an alternator. The alternator runs at 1200 rpm, so that is the ns. So ns is 1200. Okay, so from this we have to find out the frequency. then having a flux per pole is 0.1 Weber. So flux phi is equals to 0.1 Weber. Then slots, 54 slots and 8 turns per coil. Okay. And coil is short pitch by 1 slot. So alpha is equals to beta here. Okay. Now this is the given data they have given. Now we have to find out, they have given us Ns. So from this Ns I can find out F. We know that Ns is equals to 120 F by P. So put here and get the F as 60 Hertz. Okay. Then small n is equals to slots per pole. So how many slots are there? 54 slots of 6 poles. Okay. Then you will got n as a 9. Then m, slots per pole per phase. So slots per pole are 9, per phase is 3. Okay, so 9 by 3 is 3. Similarly, you can find out beta. Beta formula is 180 upon n. So 180 upon n is 9. So again you will get beta as 20 degree. As I have told you, the coil is short pitch by 1 slot only. So alpha is equals to beta, that is 20 degree. Okay. So I can easily find out Kc here. So Kc is equals to cos of alpha by 2, which is cos of 10. So it will be 0.9848. Okay. Then I will find out Kd. Similarly, by putting the value in this formula, I will get Kd as 0.9598. Okay. Now in this problem, they have given us the winding is double layer. Now what is the meaning of double layer is, see, in case of double layer you have two coil sides placed in a single slots. Okay. So they have said 8 turns for one coil side and 8 turns for second coil side. Okay. So 8 plus 8, 16 conductors are total present in one slot. Okay. Now see here, as the winding is double layer, in each slot there are two coil sides. Okay. Of each coil has 8 turns. So two coil side each is having 8 turns. So 8 plus 8, there are total 16 conductors. So total conductors is equals to slots into conductors per slot. So slot are 54, then the conductors in one slot is 16. Okay. So 54 into 16, it will be 864. Okay. So ZPH 864 by 3, that is 288, and TPH ZPH upon 2, that is 144. Now you have all the values. You have Kc, Kd, Phi, F and TPH. Now put the values of all in this formula and you will get the EPH. Now again by getting EPH, again your alternator is star connected. So you have to convert it into EL by multiplying it with the root 3. So root 3 into EPH, you will get 6.2803 kilovolt. So this is the value of your EPH. So this is the best possible way to explain how to find out or how to calculate the EMF of a alternator by using the Kc and Kd. Thank you very much.